right, let's take a look at today's lesson. So we're going to be graphing exponential and logarithmic graphs and working with transformations. We have done that before. Actually, it was a different unit. We did this in Unit 2, Lesson 6. So if you want to go review what all the plus h and minus k, all that means, you can get some more specific detail there in Unit 2, Lesson 6. So what we're going to do is work with parent functions first. So this is a parent function because it doesn't have any transformations on it. There's no like plus 5 or anything like that. There's no transformations. And so this is a parent function. And the asymptote for these are exponentials. The asymptote is the x-axis. Okay, that's for the parent. So for transformations, this asymptote will only move. So the asymptote will only move with up, down shifts. Okay, so it will only move with up-down shifts. That's the only way it's going to move. So here, let's go ahead and draw the asymptote for this parent function. So it's on the x-axis. And let's go ahead and plot some points. I like to do like -1, 0, 1, 2. I like to do those. So 2 to the -1 is 1/2. 2 to the 0 is 1. 2 to the first is 2, and 2 squared is 4. All right, let's plot those points. So we've got, let's see, -1 and then 1/2. Then we have 0, 1. We have 1, 2, and 2, 1, 2, 3, 4. Okay, so here's our graph. It kind of goes flat right there. Okay, so that's a parent function graph. Let's graph, and let's just remind ourselves from the last lesson, if you recall, we could either look at the graph to tell whether it was exponential growth or decay, or we could look at the equation. In this case, this one is exponential growth. And just as a reminder, this exponent is positive, so that was the other way to tell, either by looking at the graph as we read it from left to right, it's increasing, so that's growth. And the equation has a positive exponent. Okay, so let's look at our next one. Again, this is a parent function, so we're going to do -1, 0, 1, 2. Let's go ahead and graph our asymptote. All right, so let's see. So 1/2 to the -1, if you recall, that means it kind of flips it upside down. It gives me a 2. 1/2 to the 0 is 1. 1/2 to the first is 1/2, and 1/2 squared is 1/4. All right, so let's graph this one. So -1, 2, 0, 1, 1, 1/2. And 2, 1/4. Okay. Ooh, this one is, as we're reading it from left to right, it's falling. So this one is decay. But look at that equation. That equation doesn't have a negative there. Let's think about that. So how else could I write this portion in here? How else could I write that besides 1/2? Let's think about that for a second. So this is the same thing as 2 to the -1, right? That's the same thing as 2 to the -1. So if we do 2 to the -1 to the x, that's where we get our negative exponent right there is -x. Okay, so that's just some practice with some parent functions. Let's do one more parent function. Let's do a log parent function. Now for the log, if you know, this is the parent function for a log right here. This is a parent because there's no transformations on it. You know, there's no, I don't know, -2 or anything like that. So this is a parent, and the parent has an asymptote. The log parent is the y-axis. Okay, and so the only way it moves, so the asymptote moves with only with left right shifts. Okay, so this time this one moves with the left right shift. All right, well, let's go ahead and draw this asymptote. It's on the y-axis. Great. Okay, now if you recall, we have a couple lessons ago, we did graph a logarithm. We have to do that circly thing. Remember, we have to change it. So this f of x is actually a y. They mean the same thing. And we do that circly thing. Remember that? 2 to the y equals x. So we rewrite it as an exponential just to make our lives easier, right? It's going to be easier to plug numbers in for the y rather than plug numbers in for the x. It'd be super, super hard to plug numbers in here in this x right here. That would just be really hard. Why? When we can convert it to an exponential and then just use exponentials. Seems much easier. So 2 to the -1 is 1/2. 2 to the 0 is 1. 2 to the 1 is 2. 2 squared is 4. Okay, so let's plot these points. So we have 1/2, -1, 1, 0, 2, 1, 1, 2, 3, 4, 1, 2, and 4, 2. Okay, so it goes kind of like that. All right, so there's our parent logarithm. All right, so, oh, looky here, we get to dig back into our memory again, finding inverses. Let's remember, does anybody remember what the steps we take to find the inverse? And let's just remind ourselves, that's y. Okay, so step 1, what we do is we switch the x's and the y's. We switch them. Step 2, we solve for y. I mean, that's what we do. Okay, so let's do step 1. Let's switch the x and the y. So instead of writing y equals, we're going to write x equals. And instead of x minus 1, we're going to write y minus 1. Okay, great. We did step 1. Now to solve for y, the first thing we need to do, we need to get this little beast right there by itself, right? That term with the y in it needs to be by itself. So let's move the 4 over. So x minus 4 equals 3 to the y minus 1. Now, how would we get the y out of the exponent? So if you recall, we have before turned an exponent into a logarithm, and perhaps you didn't notice what happened to the exponent, but the exponent became the argument, or basically became the answer, to the log. So now recall, so this is a base 3 exponent, so my log that I'm transforming would be base 3, and then we reach over to the other side of the equal sign, and that equals our exponent. Kind of, I guess you could think of it as a circly thing also if you wanted to. You could say this, you know, that's the base of the log, and then you pick up this part, and then you end at the y minus 1. Okay, so let's solve for y. We have one more step. Let's move the 1 over. So y is 1 plus log base 3 of x minus 1. The reason that we went through this exercise where we're finding the inverse is so that we could really realize and point out that exponentials and logarithms are inverses of each other. They are very closely related. Okay, they are inverses of each other, and this is a demonstration of how that happens, how they are. All right, 2 questions. Oh, now we get to do the transformations. Yay. Okay, so first thing is, isn't that so fun when it just goes crazy and decides to, let's just jump somewhere else. Oh, well, let's do that again. That was so much fun. Why not do it again? Come back, little thing. Here we go. Okay, maybe it was a little upset that we're on the last problem. I don't know. All right, so the first thing that we want to do is we want to write down what the parent equation is, or the parent function. So in this case, and f of x, remember, is y. So y equals 2 to the x. That is the parent. So what did I do? I took off the, this minus 3 is gone. That's a transformation. I took off the 2, right? And I just left the 2 to the x. That's the parent. That's how we find the parent. All right, so what we're going to do is we're going to graph the parent, and then we're going to graph the transform. We're going to talk about what transformations exist on number 5, and we're going to graph the new, the transformed equation. So we've been graphing the parent ones for a while, -1, 0, 1. You can add some 2's and -2's in if you want, just so you can get a good picture of what's going on. 2 to the -1 is 1/2, 2 to the 0 is 1, 2 to the 1 is 2. This is an exponential, so it's got a asymptote right here on the x-axis, and so let's graph those points. -1, 1/2, 0, 1, and 1, 2. And if these aren't enough points for you to figure out what it looks like, just graph some more. It'll be fine. Just graph as many as you need to figure out what that's supposed to look like. All right, so now we've got the parent done. That's dealt with. Now let's talk about transformations. So first up, let's look at this one right here. Okay, hopefully we remember from, our last semester what kind of transformations. That's trapped up there with the x, so it's an x transformation. And so this particular transformation, and I know x's are just fussy. They are always opposite. So what this means is we're supposed to go left 2. And what does that do? So left 2, it affects the, it's a horizontal shift, so it affects the x value. So the x value, what we're going to do is we're going to subtract 2. We're going to subtract 2 from all x values. That's what we're going to do. We're going to subtract 2 because that's what that transformation says. So now let's look at this transformation right here. Let's see. So what is that? That's larger. It's not trapped up there with the x. So this is a y transformation. This means, and y transformations are just so nice. It really does mean, down 3, just like it looks, down 3. And so that affects the y value. Okay, the y value is affected, and what would we do? We're going to subtract 3 from all the y values. Okay, so let's start our transformations. So I'm going to take all the x's, and I'm going to subtract 2 from every one of them because, this is what this says. We subtract 2 from all of our x's. So let's do that. So let's see, -1 minus 2 gives me -3. Let's just put the points in a different color because that's what I'm going to graph in. 0 minus 3 is a what? What are we doing? 0 minus, it's left 2, sorry, minus 2. 0 minus 2 is a -2. And then 1 minus 2 is a -1. So we subtracted 2. All right, now from all the y values, these y values right here, what we're going to do is we're going to subtract 3 from the y values. So 1/2 minus 3 would be -2.5. 1 minus 3 would be -2. And 2 minus 3 is -1. So those are our transformed points. Now let's think about this for a second. we also are probably going to have to transform the asymptote. Let's think about that. So we up here, we talked about what would move a asymptote on an exponential. What would move? The up-down shifts would move. Think about it. Think about this as a barrier. What would happen if you went from above or below to the barrier? These asymptotes have to stay with the function itself. So if this function moves up, the asymptote's going to move up with it. But if the function moves left and right, okay, well, it doesn't affect the asymptote. It would be just sliding left and right. That's why the up-down shifts affect exponentials asymptotes. Okay, so let's go back and look at the exponential. So I think we did have an up-down shift. Let's see. Yeah, we went down 3. So for our new asymptote is going to be down 3. So it's going to be right here. Okay. And let's graph our points. So we've got -3, -2.5. Then we've got -2, -2, and -1, -1. And so we look something like this. All right, so there is our transformed one. Okay, great. One more. All right, so let's look. So parent function, okay, let's pull all the transformations off, and we see the parent would be log base 4 of x. Okay, let's deal with graphing the parent. Remember a logarithm. We want to, do our circly thing. We want to turn that into an exponential because it's way too hard to graph and find x values. I mean, who knows what log base 4 of 2 is? I mean, who knows that in their head, right? But if I did 4 squared, I would know that. So that just makes our life easier. So we're going to do -1, 0, 1 again for y's this time, because again, this is the one where it'll be easy for us to find. It's just because it would be easy. It's not because I have to, it just would be easier. So 4 to the -1 is 1/4. 4 to the 0 is 1, and 4 to the first is 4. Okay, so logarithms is a parent, right? It's a parent, so it's going to have its asymptote right here. So let's graph our points. 1/4, -1, 1, 0, and 4, 1. 1, 2, 3, 4, 1. Okay. And so let's go like this and like that. Okay, great. We have the parent graphed. All right, good job. All right, now let's work on transformations. Oh, we got a lot going on there, don't we? Let's work on this one first. Okay, this one. That one is affected the x, right? It's actually opposite of what it looks like. So we're going to go left 1, which means it affects the y value. And what we're going to do, excuse me, yeah, the x value. I said y, but I meant x, and I wrote x. Yay! It affects the x value by going what? Left 1, so we would need to subtract 1. Okay, so we're going to subtract 1 from our x values because, it's left 1. All right, so let's take a look at this one. Okay, this one right here. Okay, that's a +3. It's not inside there with the x, so that's going to be a y transformation. All right, so this would be up 3. So my y values, I'm going to add 3 to them. Okay, I'm going to add 3 to my y values. Okay, great. All right, now for the weird one. Do you see which one we haven't done yet? Yeah, look at that multiplier right here. This multiplier, the multiplier of -1 to the log. Let's kind of dig back into memories. What does that mean when we multiply by negative? Yeah, so if we multiply it like the y value by negative, it's going to reflect it. So this is a reflection over the x-axis. Which means we're going to take our y values and we're going to multiply by -1. So we're going to take all the y values, multiply by -1. Whoo, we got a lot going on there. So these are y, we got 2 y transformations this time, and we have just one x transformation. Okay, well let's do the x first. That seems easiest. All right, let's transform the x's first. Okay, so I'm going to take all the x's and I'm going to subtract 1. So 1/4 minus 1 is -3/4. 1 minus 1 is 0, and 4 minus 1 is 3. Whew, that wasn't too bad, right? Now we're going to have to, again, think back. If I have 2 different transformations for y's, which one am I going to do first? Does it matter? Absolutely it matters. Should we multiply